Hi everyone, so this video is going to be about Venn diagrams. So as with many of the sections we've seen thus far in this unit, this one has a lot of new vocabulary potentially for you and some new symbols as well. So let's just dive right in. So what is a Venn diagram first? So a Venn diagram is sort of a visual representation of this universal set, which is represented by the letter U. So the universal set is going to be different for each question. So it might be, the numbers 1 to 20 might make up the universal set, or it might be a group of students might make up the universal set. So it's going to be different depending on each question. But then what a Venn diagram does, and this is going to be sort of the most stereotypical version of a Venn diagram, is it takes this universal set, U, and it places every element from that set somewhere inside the rectangle. So then oftentimes we will see this year two sets within the universal set, and we'll just randomly label them A and B, but again, that's going to depend on the question that you're looking at. But that's sort of a stereotypical version of a Venn diagram. So universal set, all elements under consideration. So again, the universal set is dependent on the particular question that you're looking at. But for the sake of this sort of video, let's look at the universal set is, let's go integers from 1 to 10, and we'll say inclusive. So meaning including 1 and including 10. So if we wanted to list the elements of the universal set, we would list all of the numbers from 1 to 10, including 1 and 10. So those are all of the numbers that are in play. And if we were eventually going to put this on a Venn diagram, those are all of the elements that would have to find a home somewhere inside the rectangle. Every number must be accounted for. Okay, let's go to some more new terminology. The complement of a set. Pay attention, this is complement with an E, meaning goes together, not complement with an I, meaning you look really nice today. So S prime, so this little S with the sort of straight apostrophe, if you will, that reads S prime, and that notation denotes the complement of S, and it could be any letter. So you could have sort of set A, and then you would have A prime, which would be the complement of A. So the letter is not so important, but that straight flattened out apostrophe is what denotes complement. So it represents all of the members of U that are not part of S. So when you put them together, they give you the entirety of U. So imagine for a moment, thinking back to our universal set, which is the numbers 1 to 10, let's imagine that S is even numbers. So then that would include, oh, that's terrible, 2, 4, 6, 8, and 10. And then S prime is everything that is in U that is not part of S. So that would list then 1, 3, 5, 7, and 9. So all of the odd numbers essentially. So put the two together, the original set and its complement, and you get everything that was part of the universal set. Okay, so subsets are a little different. So subsets, and here we have another new symbol, this sort of C with the straight line underneath, that represents subsets. So when we see A is a subset of B, that means every element of A is also in B. So if we go back to our previous example here, where we had S was the set of all even numbers, and let's imagine a new set, let's go with B, and B is, oh, hold on. Let's imagine that B is 2, 6, and 10. Those are the three elements of B. Well, we could say that B is a subset of S because every element of B is in S. So every element of B is part of S, therefore B is a subset of S. Okay, one more. So the empty set, we call an empty set, or we call a set empty if it has no elements. And it's represented by one of two symbols, either sort of the circle with the line through it, or the two sets of fancy brackets with nothing inside. So all an empty set means is that it has no elements. So if we think back to our universal set, which was the numbers 1 to 10, within that, if C was, let's say, 11, 15, and 20, those were the three numbers that were part of C. Actually, that's not a really great example. Let's imagine that C was odd and even numbers. Well, there's no numbers between 1 and 10 that are both odd and even, so that's an impossibility. I guess the other example could have worked as well. Both impossibilities within the set of U. So those would be considered empty sets in this universal set because there's no element that fits the bill. Okay, let's work through a Venn diagram example. So we've got this universal set here in interval notation, so let's break this down. So X it's a set of X such that 0 is less than or equal to X, which is less than or equal to 12. So U is all the numbers between 1 and 12, and X is a member of Z, which is a member of the integers, so that means all the whole numbers between 0 and 12, including 0 and 12. So when we construct our Venn diagram, we have to have every number from 0 to 12 represented somewhere. Then we have a little bit more information here. We have set A, which includes the numbers 2, 3, 5, 7, and 11. And then we have set B, which is 1, 3, 6, 7, 8. We're asked to show this on a Venn diagram. So the first thing you need to do is draw yourself your large rectangle to represent the universal set. So every number from 0 to 12 has to get in that somewhere. So what I find helpful, let's draw our two circles, one for set A and one for set B. What I sometimes find helpful is to write all of the numbers out and then just kind of go in order. And that way you tend not to miss any, because the worst thing with a Venn diagram is to accidentally forget one of the elements. So if we go in order, it tends to be a little bit easier, in my opinion. So if we look at our 0, 0 is not in set A and it's also not in set B. So 0's got to go on the outside somewhere. 1 is in set B only, so 1 goes there. 2 is in set A only, so it needs to go in that circle. 3 is in both A and B, so it's going to go into this overlap section in the middle to show that it is in the circle that represents B and it's also in the circle that represents A. 4 is in neither circle. 5 is in just A. 6 is in just B. 7 is in both A and B. 8 is in just B, 9 is in neither, 10 is in neither, 11 is in just A, and 12 is in neither. Do yourself a favor when you finish these. Make sure that you have all of your numbers. So I've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and that's what I need to have. I need to have everything from 0 to 12, including 0 and 12, somewhere represented in my Venn diagram, and I have done that. Okay, so that does it for sort of the introduction to Venn diagrams. We will get further into them in the next couple of sections, including my favorite, which is the word problems with Venn diagrams, but that's it for the introduction.